Children, it is a continuation of the solution of the model question paper 1 given by KCEB. Now let us take the 34th question. Question number 34. Find the solution of the following pair of linear equations by the graphical method. The pair of linear equations is given here. 2x plus y equals 10 and x plus y equals 6. Now you take the first equation. So that is the solution. We have to solve this pair of linear equation by graphical method. Now you take the first equation, 2x plus y equals 10. Then you express in terms of y and transfer this 2x to the RHS. Then it becomes y is equals to 10 minus 2x. Y is equals to 10 minus 2x. Now find two set of coordinates taking some value for x and finding the corresponding value for y. So you take when x equals, you take any value for x, that is the convenient value. Take when x equals 0, then y is equals to, then y equals 10 minus 2x means 2 into 0, that equals 10 minus 0 equals 10. Then when x equals, you take 1 or 2 or whatever it may be. When x equals 1, then y equals 10 minus 2 into 1, that equals 10 minus 2 ones are 2. 10 minus 2 equals 8. Then you take one more value, x equals 2. When x equals 2, then y equals 10 minus 2 into 2 equals 10 minus 4. 2 2s are 4. That equals 6. That is, when x equals 0, then y equals 10 minus 2 into 0. When x equals 1, then y is equals to 10 minus 2 into 1. And when x equals 2, then y equals 10 minus 2 into 2. So you got the corresponding y value 10, 8, 6. Now you make a small chart, that is x, y. X values are 0, 1, 2, 0, 1, 2. Corresponding y values are 10, 8, 6. 10, 8, 6. Now you take the second equation, x plus y equals 6. So you take second equation, x plus y equals 6. That is the chart for the first equation. Now you consider the second equation. Again you write it as y is equals to 6 minus x. You write it in the form of y is equals to mx plus c. So you got y is equals to 6 minus n, 6 minus x you got. Then take some values for x when x equals, right, when x equals 1 or 0, whatever it may be, you take, let us take 0. Then y is equals to 6 minus 0 equals 6. When x equals 0, then y is equals to 6 minus 0. Then you write, when x equals 1 you take, then y equals 6 minus 1, because that is 6 minus x. In the place of x, what you have tried? 1 you have tried. So it becomes 6 minus 1 equals 5. When x equals 2, then y equals 6 minus 2 equals 4. Then for 0, 1, 2, you got 6, 5, 4. So write the chart here, x, y. The values of x are 0, 1, 2, 0, 1, 2. Then the values of, corresponding values of y are 6, 5, 4. So you got the set of coordinates for the second equation, x plus y equals 6. Now let us plot the points on the graph sheet. The first equation is 2x plus y equals 10, and you got the set of coordinates when 0 is when x equals 0, that is y is 10, 0, 10, 1, 8 and 2, 6. And the second equation is x plus y equals 6, and the set of points are here 0, 6, 1, 5, 2, 4. Now draw the perpendicular axis on the graph sheet and count the number of boxes here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26 are there. So you can make 13 above and 13 below. So you take 3 plus 3 plus 3 and let us take here. Draw the horizontal axis, which is the x-axis. Now here again take the middle of this. So let us have here approximately middle it is. So let us take little above. Now this is the origin and mark the point here. Zero and you write the scale here. What is the scale? Scale on x-axis 1 cm equals 1 unit, or both you have taken same. So you take scale 1 cm equals 1 unit. 1 cm equals 1 unit. So this is the origin. Now you take 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, so on. Here minus 1, minus 2, minus 3, minus 4, minus 5, minus 6, minus 7, minus 8, minus 9, minus 10, minus 11, minus 12, so on. And above the positive 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Below minus 1, minus 2, minus 3, minus 4, minus 5, minus 6, minus 7, minus 8, minus 9, minus 10, minus 11, minus 12, minus 13, minus 14, minus 15, so on. Here also continue it. Now let us locate the point here. First one, for the graph 2x plus y equals 6, 0, 10. So 0 is here, 10 means you mark here. This is 0, 10. Then 1, 8, 1 is here and you mark 8. Then 2, 6, 2, 6 comes here. Now you join this point to get the straight line. So this is the graph of 2x plus y equals 10. 2x plus y equals 10. Then you take this one, 0, 6, 1, 5. 0 comes here, 6, 1, 5. 1, 5 is here. And 2, 4. 2, 4 comes here. Now let us mark these 3 points. And better to, this is 0, 10, this is 1, 8, and this is 2, 6. Then this is 0, 6, 1, 5, and this is 2, 4. And these two meet at a point 4, 2. You know that you will get the intersection of the two lines. This is a graph of x plus y is equals to 6. And both the straight line meet at a point 4, 2. Meet at a point 4, 2. So this is the solution. Here you got that x is 4 and y is 2. So x equals 4, y equals 2 is the solution. Verify here. If you put x equals 4, 2 into 4 plus 2, that is 8 plus 2, 10 you will get. Here also 2 plus 4 equals 6 you will get. So this is the solution. So you write solution x equals 4, y equals 2. X equals 4 and y equals 2 is the solution. Now question number 35. Here there are two questions. Answer any one of the question. It is a choice question. So here or question is there. So you write the answer for this question or this question. Now let us solve first question. An arithmetic progression consists of 37 terms. The sum of the first 3 terms of it is 12 and the sum of its last 3 terms is 318. Then find the first and last terms of the progression. So let us solve it. To take that solution for the first one, you take what are given here. An arithmetic progression consists of 37 terms. Means here n equals 37. And also it is given that the sum of the first 3 terms means a1 plus a2 plus a3 equals how much? 12. Sum of the first 3 terms is 12. And you know that a1 means a, a2 is a plus d, a3 is a plus 2d equals 12. Then it becomes a plus a is 3a and d plus 2d is 3d equals 12. Then you remove a common, a 3 into a plus d equals 12. Then you can cancel 3 1s are 3 4s are. You got that a plus d equals 4. Now you express this in terms of a or in terms of d. Let us write it as a is equals to 4 minus d. Consider this is the first. Here what you have done, we have taken the first relation a1 plus a2 plus a3 equals 12 and finally you got this one, a is equals to 4 minus d, and you consider this is first. After that one more relation is there. The sum of the last 3 terms is 318. Last term means here this AP is containing 37 terms. The last term is A37 and its previous term is A36 plus A35. This is the sum of the last 3 terms, A37, A36 and A35. That equals how much it is given? It is given that 318. 318, you write it. 318. And A37 is A plus 36D plus A36 is A plus 35D plus A35 is A plus 34D equals 318. Why you have to write A plus 36D, A plus 35D, A plus 34D? Because you know that AN equals A plus N minus 1 into D. That is 1 less than N. So here A35 means A plus 36D, A36 is A plus 35D, A35 is A plus 34D. Now A plus A, it becomes 3A, and 36D, 35D, 34D. Add this 36, 35, 34. It becomes 6 plus 5, 11, 11 plus 4, 15. Carry 1. 4 plus 3, 7, 7 plus 3, 10. You got 105. So it becomes 105D equals 318. Now you can remove 3 common because all these are in the table 3. This is divisible by 3. This is also divisible by 3. So remove 3 common. It becomes A plus 3, 3, 9. 1 is remaining. 3 5s. 35D equals what? 318, you write. Then you can cancel 3 1s. 3 1s 3, 0, 6. So you got that A plus 35D equals 106. Then in the place of A, you write 4 minus D. That is from first you write 4 minus D. 4 minus D plus 35D equals 106. Then here you give the reason from first. Then it becomes 4 minus D plus 35D is 35 minus 1, that is 34D equals 106. Now 34D, you transfer this 4 to RHS, that becomes 106 minus 4. So you will get 34D equals 106 minus 4 is 102. And then D is equals to 102 by 34. You know that 34 3s are 34 into 3. 4 3s are 12. 3 3s are 9 plus 1, 112. So you get 34 1s are 34 3s are. You got that D equals 3. D equals 3. Now you substitute the value of D in the first relation. What is that first? That is A equals 4 minus D, right? A equals 4 minus D, that equals 4 minus D means 3 equals 1. You got A equals 1 and D equals 3. Here what you have to find out? The first term and last term. First term you got and the last term is A37. You take A-N equals A37 equals question mark. Then you write the formula for AN or A37 directly you can write A37 equals what? A plus 36D, that is A is 1. 1 plus 36 into D is 3. Then 1 plus 36 3s. 36 3s, 6 3s 18. 3 3s 9 plus 1 10. You got 108. So A37 equals 109. So first term A1 equals 1. Last term A37 equals 109. You got the answer. Now you take the OR question, the second question of that mean. The sum of the first 7 terms of an arithmetic progression is 140 and the sum of the next 7 terms of this same progression is 385. Then find the arithmetic progression. Here what is given? The sum of the first 7 terms of an arithmetic progression is 140 and the sum of the next 7. Here what is given? A1 plus A2 plus A3 plus A4 plus A5 plus A6 plus A7 equals 385. And also next 7 terms means A8 plus A9 plus A10 plus A11 plus A12 plus A13 plus A14 equals how much? This is 140. This is 140 and this is 385. 385. Then you write, here you take first one. A1 means A plus A plus D plus A plus 2D plus A plus 3D plus A plus 4D plus A plus 5D plus A plus 6D. A1, A2, A3, A4, A5, A6, A7. So you got it. That equals 140. Now you will get one relation here. So 1, 2, 3, 4, 5, 6, 7 A's are there. So you write 7A plus D plus 2D, 3D plus 6D plus 10D, 15D plus 6 means 21D equals 140. Now here you can remove 7 common. So remove 7 as a common. In the bracket you will get A plus 3D equals 140. Then 7 ones are 7 20s are. So you got that A plus 3D equals 20. Then you express in terms of A. So you get A is equals to 20 minus 3D. That is one relation here. You can use that for the next relation. Now you take this one. It is A8 plus A9 plus A10 plus A11 plus A12 plus A13 plus A14 equals how much? 385. And you write A8 means A plus 70 plus A plus 80 plus A10 means A plus 90, A11 means A plus 10D, A12 is A plus 11D and A13 is A plus 12D and A14 is A plus 13D equals 385. Now again you will get 1, 2, 3, 4, 5, 6, 7A. 7A plus D 7 plus 8, 15, 15 plus 9, 24 plus 10, 34, 34 plus 11, 45, 45 plus 12, 57, 57 plus 3, 60, 60 plus 10, 70. So you will get here 70D equals 385. Again you remove 7 as a common. In the bracket you are going to get A plus 10D. That equals 385. Then 7 ones are. So you can cancel here. 7 5s are 35. 3 is remaining. 7 5s are. So you got that A plus 10D equals 55. Then you got A equals, substitute here. That is 20 minus 3D. 20 minus 3D plus 10D equals 55. That is from first you got it. Then it becomes 20. 10 minus 3 is 7. That is plus 7d equals 55. So 7d equals 55 minus 20. That is 7d equals 55 minus 20 is 35. So you got d equals 35 by 7. 7 ones are 7 5s are. D equals 5 you got. Then substituting this value of d in this equation. So you take from first what? A minus, what is here? A is equals to 20 minus 3d. A is equals to 20 minus 3d. So A equals, you will get 20 minus 3 into, if you consider this is second, then you can write 5, that is from second. Then you will get A equals 20 minus 15 equals 5. Then here what you have to find out? Find the arithmetic progression. Find the arithmetic progression. Then you got A. Next term you take. This is A1. A1 equals A equals 5. A2 equals A plus D. That is 5 plus, or directly you can write A1 plus D. A1 plus D, that is 5 plus D is also 5. 5 plus 5, 10. Then A3, A2 plus D, that is 10 plus 5 equals 15. Therefore the AP is 5, 10, 15, so on. 5, 10, 15, so on. Now the question number 36. Construct a triangle with sides 4 cm, 5 cm and 6 cm, and then another triangle whose sides are 5 by 3 of the corresponding sides of the first triangle. Let us observe the construction made by a student. Children, let us consider the baseline BC of a triangle ABC is 6 and AB is 5 cm and AC or C is 4 cm. This 4, 5, 6 cm are the measurement of the sides of the triangle ABC. Here ABC is a given triangle. Now you construct the triangle ABC. Draw a baseline BC of 6 cm length. It is a baseline BC of 6 cm and AB is of 5 cm. So with B as a center, we have to draw a curve of, draw an arc of 5 cm. So you measure 5 cm and with B as a center, draw an arc. Again we have to go to the side CA of 4 cm, measure 4 cm. Measure 4 cm. With C as a center, cut the previous arc. Now you got a point A. The point at which both the arc intersect is the vertex A, and join that vertex A to B. So you will get a side AB and join that vertex to C, you will get a side AC. Now you got a triangle ABC with BC 6 cm and AB 5 cm and AC 4 cm. Now draw an acute angle at a point B, and here the ratio is 5 by 3. Ratio of the corresponding sides of the first triangle is 5 by 3, and the greater of 5 and 3 is 5. So you must make 5 equal parts on this line. So first you draw with B as center, make one part and have 5 equal parts. This is the first part. Now you draw the second arc with the same measurement. You must make 5 equal parts. Here out of 5 and 3, 5 is greater. Don't do the 5 plus 3, 8 equal parts. But here you must do only 5 equal parts. That is the greater of 5 and 3. So this is the third one. This is fourth part. Next, fifth part. So you got 5 equal parts. Here the first B1 and second B2, B3, B4, B5. In the numerator 3 is there, so you join the B3 to C. Here we have to join the part which is in the number of the denominator. So here in the denominator 3 is there, so you have to join B3 to C. Now you extend it because the ratio is 5 by 3. Numerator is greater, so it comes outside. So you joined B3 to C because 3 is there in the denominator. Now you must draw the parallel line to this line. So with B3 as a center, draw an arc, and with the same radius, draw an arc with B5 as a center. You have to draw the parallel line from the point B5, and you must get the angle here. So by using the compass, find the angle made at a point B3, and with this point, not from that point B5, with this point, that is the point of intersection of the first arc, and you got a point here, point of intersection of both the arc. Join that to B5 and produce to meet the line BC which is extended. Now you got a line which is parallel to CB3, that is C dash B5. Again we have to draw the parallel line at C dash. Do the same step here. Draw an arc with C as a center. With the same radius, draw the arc with C dash as a center. Here you must have the equal corresponding angle. Again you find the measurement of this angle at C. Now you got it. And with this point as center, cut the previous arc. Now you will get the same angle at C dash. So join that point to C dash and produce AB and join the C dash and that point to meet that the line AB which is produced. Now you got a line parallel to CA, that is C dash A dash. C dash A dash is a line parallel to AC. You got a triangle A dash C dash B similar to triangle ABC. Triangle A dash B C dash is similar to triangle given triangle ABC. Now the question number 37. A toy is made in the shape of a cylinder with one hemisphere stuck to one end and a cone to the other end as shown in the figure. The length of the cylindrical part of the toy is 20 cm and its diameter is 10 cm. If the slant height of the cone is 13 cm, find the surface area of the toy. Length of the cylindrical portion is given and the diameter of the toy is given and slant height of the conical portion is given. So you write for conical portion, so you write the solution here. Conical portion again R is same, R equals 10 by 2 5 centimeter and L equals 13 centimeter. For cylindrical portion, then R is same, that is 10 by 2 5 centimeter and length, that is nothing but H equals L, that is 20 centimeter. And for spherical portion, this is the spherical portion, that is hemispherical portion. For hemispherical portion R is same, that is R equals 10 by 2 equals 5 centimeter. Now here the question is find the surface area of the toy. We know that surface area of the toy equals here 3 part. First let us start from this, that is TSA of, so you take, that is the CSA, not CSA, CSA of hemisphere plus CSA of, this is the first portion, this is the second portion, this is the third portion, CSA of cylinder plus CSA of cone. First part hemispherical part, second part cylindrical part, third part conical part. Now you write the formula for CSA of hemisphere. CSA of hemisphere is 2 pi r square plus CSA of cylinder. CSA of cylinder is 2 pi RH plus CSA of cone is pi RL. So you got, here you can remove 2 pi is there, but here only 1 pi is there, therefore you can remove pi as a common. And r square is there, r is there, then r you can remove as a common. So you remove pi r outside. In the bracket here 2 is remaining and r is remaining. 2r plus, again here 2 is remaining. 2, 5r is outside. What is remaining here? H is remaining. H plus here 5r is outside. So L is remaining. L you write. Now pi is 22 by 7. R is same for all. 5. 2 into 5 plus 2 into H. H is 20 centimeter plus L, slant height of the cone, that is 13 centimeter. Now it is 22 by 7 into 5 and 2 5s are 10 plus 2 20s are 40 plus 13. Then it becomes 22 by 7 into 5 into sum of this. 40 plus 10 is 50. 50 plus 13 is 63. Then 7 ones are 7 nines are. Then 22 into 5 into 9. Then you know that 22 into 5 is, that is 5 2s are 10. 5 2s are 10 plus 1 11 into 9. So then you will get 990. 9 into 0 is 0. 11 nines are 99. Then you will get 990, and the measurement are in centimeters. So it is wall, there is a surface area. So you write 990 cm square. Therefore you write surface area of toy is 990 cm square. Surface area of the toy is 990 cm square. The last question, sixth main, answer the following question. Prove that the ratio of the areas of two similar triangles is equals to the square of the ratio of their corresponding sides. Let us prove the theorem. The ratio of the area of two similar triangles is equal to the squares of the ratio of their corresponding sides. Here there is a theorem to state that the ratio of the areas of two similar triangles is equal to the squares of the ratio of their corresponding sides. Now here take two triangles which are similar, and similar means you know that their corresponding sides are in the same ratio. Now to prove this theorem, what is given here? It is given that triangle ABC and triangle PQR are similar triangle. We are given, here let us prove, we are given two triangles ABC and PQR. ABC and PQR such that triangle ABC is similar to triangle PQR. Triangle ABC similar to triangle PQR, and if they are similar means you know that their corresponding sides are in proportion and their corresponding angles are equal. That is understood here. Now what we have to prove? We need to prove that what you have to prove? Their areas are in the ratio of the squares of the corresponding sides. So you need to prove that area of triangle ABC by area of triangle PQR is equals to, here which are the corresponding sides? You can take AB and PQ. So you can write AB square by PQ square. And also two more pairs of corresponding sides are there. And let us take BC and QR is second pair of corresponding sides. So it is equals to BC square by QR square is equals to CA square by RP square. Or you can write this in the form AB by PQ whole square and BC by QR whole square, and also it is CA by RP whole square. You can also write that like this way: area of triangle ABC by area of triangle PQR is equals to AB by PQ whole square is equals to BC by QR whole square is equals to CA by RP whole square, or you can write AB square by PQ square is equals to BC square by QR square is equals to CA square by RP square. And to prove this, here you must take the formula for the area of the triangles. You know what is the formula to find the area of the triangle? It is area of triangle is equals to half into B into H. So you take area of triangle ABC here. Area of triangle ABC, that is equals to half into B into H. Here let us have the base BC and height is required, means we have to draw the altitude here. So okay, you take here the altitudes for the triangle AB. It is so let us have here AM is the altitude, and for triangle PQR let us have PN is the altitude. And here for triangle ABC, here we have taken the base is BC. So let us write the base is BC here, BC, and the altitude is AM. So half into B into H, half into base into altitude, that is half into BC into AM. Next, for triangle PQR, area of triangle PQR is equals to, that is again half into B into H. Here B is QR, H is, that is PN. So you take that. So half into QR into PN you write. QR into PN. That is half into QR into PN. So you got the area of the triangle ABC and area of the triangle PQR. Now you write the ratio. Area of triangle ABC by area of triangle PQR is equals to, in the numerator you write the area of the triangle ABC, that is half into BC into AM. Here you write half into QR into PN. Now here half cancels. What you are going to get? That is BC into AM by QR into PN here. QR into PN. So you consider this is first ratio you got in terms of the product BC into AM by QR into PN you got here. Take triangles ABM and triangle PQN and prove that they are similar. By using any one of the similarity criterion, you prove that triangle ABM and triangle PQN are similar triangles. And here you write the names of the triangle ABM and triangle PQN. Here you have in triangle AMB, sorry, right? In triangle AMB, and triangle PNQ, right? Angle B is equals to angle Q. Why? As triangle ABC is similar to triangle PQR. You know that the corresponding angles of the similar triangles are equal here. Corresponding angles of the similar triangles are equal. Therefore, you can write angle B is equals to angle Q. That is, indirectly it is given here. Next, you write angle AMB. You know that as AM is perpendicular to BC, angle AMB is 90 degree, and also in triangle PQR, PN is perpendicular to QR. Therefore, angle PNQ is also equals to 90 degree. So, you write angle AMB is equals to angle PNQ. Both are equals to 90 degree. That is the construction it means in such a way that construction is made as AM perpendicular to BC and PN is perpendicular to QR. So, you can write, therefore, triangle AMB is similar to triangle PNQ here. PNQ. So, which similarity criterion you got here? AA similarity criterion. AA similarity criterion. Then, once you got that, here triangle AMB is similar to triangle PNQ means their corresponding sides are in same proportion. Corresponding ratio of the corresponding sides are equal here. Therefore, you can write AM by PN is equals to, right? AM by PN is equals to, you can write AB by PQ. AB by PQ. Why it is? Because the ratio of the corresponding sides of similar triangles are equal. That you can reason here. So, you consider this is second, and here you have taken first. You write it as first. This is second. The reason is, corresponding sides of the ratio of corresponding sides, ratio of corresponding sides of similar triangles are equal. So, you got AM by PN is equals to AB by PQ, as you proved that triangle AMB is similar to triangle PNQ. Now, also it is given that triangle ABC is similar to triangle PQR. Also, triangle ABC is similar to triangle PQR, that is given here. As triangle ABC is similar to triangle PQR, can have their corresponding sides are in same ratio. So, you write AB by PQ. AB by PQ is equals to BC by QR is equals to AC by PR. That is, AB by PQ is equals to BC by QR is equals to AC by PR. That is, reason you know, the ratio of the corresponding sides of similar triangles are equal here. Now, you consider this is third one. Now, here AB by PQ is equals to BC by QR is equals to AC by PR, and also it must be equals to AM by PN. You know that here AM by PN is equals to AB by PQ is equals to BC by QR is equals to AC by PR. Here this is equals to this, means this must be equals to this, also equals to this, AC by PR. So you can have this BC by QR into AM by PN in terms of AB by PQ, in terms of AB by PQ here. So you can write here BC by QR into AM by PN as AB by PQ into AB by PQ. From first you had that area of triangle ABC by area of triangle PQR is equals to BC by QR into AM by PN. Now in the place of BC by QR you write AB by PQ. You write AB by PQ here. So right, this is AB by PQ and you write AM by PN here. Here in the place of BC by QR you wrote AB by PQ, that is from first and third it is. From first and third you wrote this, that is here in the place of BC by QR you wrote AB by PQ. Here AB by PQ into AM by PN you got here. Now also you know that AM by PN is equals to AB by PQ. AB by PQ and AM by PN are equal. From second you can write both are AB by PQ into AB by PQ. Both are here AB by PQ. So here it becomes, that is from second it is. That is from second. Now here it becomes AB by PQ into AB by PQ, it becomes AB by PQ the whole square. AB by PQ whole square. Therefore you can write area of triangle ABC by area of triangle PQR is equals to AB by PQ whole square is equals to AB by PQ is also equals to BC by QR. So you can write BC by QR whole square, that is also is equals to AC by PR, that also you can write AC by PR whole square. So in short you can write AR triangle ABC by AR triangle PQR is equals to AB by PQ whole square is equals to BC by QR whole square is equals to AC by PR whole square. In this way you prove that area of similar triangles are proportional to the squares of their corresponding